So in this example, we want to graph secant x, which we know is equal to, it is the reciprocal function of our cos x function. Secant x is equal to 1 over cos x. So where we're going to start is we are going to sketch a graph of our cosine function that we've done previously. So divide up our x-axis here, 2 pi, pi, pi over 2, 3 pi over 2, and we'll go negative pi over 2. And we know that our cosine function is going to start up here at positive 1. It's going to go down to 0, reach negative 1 at pi, back up, and so on and so on. And over here, it's going to come down like that. So this is positive 1, and this is negative 1. So if we want to take this knowledge and apply it to graphing secant x, let's, similar to what we did with the sine function, say what is going to happen to secant x when cos x has particular values. So let's say when cosine x is equal to 0, what is going to happen here? Well, we're going to have 1 divided by 0, which is going to be undefined. So secant x is going to be undefined. I'll just put DNE for does not exist. So that's going to correspond to a vertical asymptote in our graph of secant x. Similarly, if cosine x is equal to 1, then secant x is going to equal 1. We're going to have 1 over 1, which is just 1. Whereas if cosine x is equal to negative 1, it's reaching its minimum value, secant x is going to be equal to negative 1 as well. Put a comma in there between them. So let's start setting up our graph of secant x here. We will start at 2 pi, pi, pi over 2, 3 pi over 2, negative pi over 2, and we'll put on 1 and negative 1, just like that. So our points where cos x equal to 0 correspond to vertical asymptotes. So let's put in our vertical asymptotes here. We're going to have 1 at negative pi over 2, 1 at pi over 2, 1 at 3 pi over 2. And I think you can guess we're going to have another one over here at our next interval of pi by 2, which is going to be, what, 5 pi over 2. 5 pi over 2. Okay. Now, where cos x is equal to 1, secant x is going to be equal to 1. So where's cos x equal to 1? At x equals 0 and at x equals 2 pi. Where's cosine x equal to negative 1? At x equals pi. So we'll add that point in right there. And now let's think about where our curves are positive or negative. So, going from our cast rule again, let's see, going up to our cosine function, we know that our cosine function is positive, positive, then negative, negative, then positive, and then it's going to be positive again. Okay? So the sign of our secant function is going to be exactly the same. Where cos x is positive, secant x is just 1 over cos x is going to be positive. So if we go to our first little interval here between our asymptotes at negative pi over 2 and pi over 2, our secant function has to be positive in both cases. So it's going to approach these asymptotes just like this. In our next interval between the asymptotes at pi over 2 and 3 pi over 2, it's going to have to be negative. So it's got to approach the asymptotes like this, heading off to negative infinity at both of them. If we come back to our next interval here, 3 pi over 2 to 5 pi over 2, our graph has to be positive. So it's going to approach these asymptotes, tending towards positive infinity. And there is our graph of secant x, somewhat similar to our graph of cosecant x that we did with relation to our sine function. So now let's talk about these things that we've been talking about for each one of these. Let's start with our domain. Our domain here is going to be, well, it's going to be all real numbers with the exception that x cannot equal these points that do not exist. So it's going to be, like we did before, pi over 2 plus k pi, where k can be plus or minus -1, and so on and so on. Our range, similar to our cosecant function, for the secant function we are limited to y values that are greater than or equal to 1 or less than or equal to -1. Period is going to be 2 pi. We can see that because if we look at the points where it reaches its value of -1, the minimum for this sort of upper bound of this curve. So it'll be 1 at 0, 1 again at 2 pi, so our period is 2 pi. Amplitude doesn't really apply because it tends off to infinity. We've got zeros. No, we don't. Does not have any zeros. And our asymptotes, again, occur at every 2 pi. So let's just say at x equals, well, we can use the same things for where it does not, for the restrictions on our domain. At x equals pi over 2 plus k pi. Okay? Or, I mean, we could say plus or minus k pi if k is going to be some positive number. And that is our graph of our function for secant x.